This lesson is building off of the last lesson where we learned about the special angle pairs, corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles, and so on. So we are going to use that information we learned from the last unit to do this unit. Now, this is a specific occurrence where we have three lines, two parallel lines, and one transversal. So this is when two of the lines that the transversal crosses, that third line crosses, are parallel, meaning they're running together. All right, so before we get into all that, let's here's a picture just to kind of give you an example. Here's the two parallel lines. Remember, we know that they're parallel by this markings right here. That shows that they're parallel if we're not told so. So that means this is the transversal. And then the idea here is if this line here and this line below it are traveling the same way, if this transversal is traveling through, it's going to hit this line the same way it's going to hit the other line. So the idea here is angles 1, 2, 3, and 4 are duplicate angles to 5, 6, 7, and 8. So we're going to keep that in mind when we're doing this. And also we're going to talk about some of the things we learned in a previous lesson about linear pairs and verticals and so on and so forth to help us figure out a lot of this information. And again, I just wrote down here, recall about vertical angles from the last chapter being congruent. Vertical angles are the ones that are across from each other, like 2 and 4 and 1 and 3. A linear pair are the ones that are attached together, called adjacent angles, like 1 and 2. They form a straight line or a straight angle, which means they add up to be 180 degrees, the two angles, which is what I have right here. That linear pair is supplementary. So out of all of this information, we should be able to fill out all of this. So the nice thing to know about this is with this kind of operation, every single angle that we're going to get answers for is either 65 or 180 minus 65. Okay, so it's going to be one or the other on all of these. All right. Okay, so we're going to put down here that angle 1 is 65. Okay, that's what I'm told right here. So if angle 1 is 65, what are some other places that it can also be 65? Well, it can be 65 here, because those two are vertical angles. We can say that 5 is 65. Why? Because these guys are corresponding. Remember the group before, these are in the same place. So corresponding angles are always equal, so these guys are equal. And again, 5 and 7 can be equal because, again, of vertical angles. All right, so all the places I've marked so far are 65s. Now, let's think about linear pairs. Okay, a linear pair, remember their total has to be 180. So 180 minus 65 is 115. That means angle 2 is 115. All right, if angle 2 is 115, angle 4 has to be 115 because they're verticals. And again, 2 and 6 can be equal to each other because they are corresponding. All right, and then these two guys across from each other are also verticals. So that's 115. Now, when we answer these questions, we already have all the answers, but the reasoning that we're putting in here is based on this. How is it related to angle 1? Okay, so how is 1 related to each one of these angles? Well, first of all, we already have all these answers in terms of measurements. Remember, little m means measurement. So we can just go down here and write the answer. So we've got angle 2 is 115. Angle 3 is 65. Angle 4 is 115. Angle 5 is 65. Angle 6 is 115. Angle 7 is 65. And angle 8 is 115. All right, so that was easy. So we got all those numbers in. Now the question is, how is 1 related to 2? So 1's related to 2. It says we're supposed to find, give us our reasoning. All right, so 1 and 2, those are linear pair. Okay, 1 and 3, they're verticals. Okay, 1 and 4, 1 and 4, linear pair. Again, remember if they're adjacent or they're attached to each other and their angles together form a straight line, then, which is this line right here, then they add up to be 180. Plus I can see that too. All right, 1 and 5. 1 and 5 is corresponding. 1 and 6 are nothing. Okay, so I would just write, well, let's see. I could say, what else could I do? I could do alternate, I guess I could do 4 and 6, alternate interior angle if I don't have a reason. I can put down alternate interior angle to 4. So I'm putting something down. Okay, alternate interior angle to angle 4. 7, okay, 7 and 1 are alternate exteriors. Angles to 1, angle 1. All right, and then 8. 8, the only reason why I know 8 is because I know 6, so 8 and 6, I would say vertical angles to angle 8. I could also say, if I wanted to, I could say linear pair. For this one, I could say linear pair with angle 5. So I guess I should say, put all these in here. Linear pair to angle 1. 4 was a linear pair to angle 1. Okay. So I have to give my reason, that's all. So this is a practice of vocabulary, and then getting these answers. So let's do the next one. Again, we're going, every single thing is either 142 or 180 minus 142, which is 38. So everybody's either 38 or 142 on all this. All right, so it says 6 is 142. All right, so let's play a game this time. We know that that's 142. We're going to find a way of getting these answers. So instead of writing them all in, we're going to go each and every one of them this time. All right, so angle 1. Well, angle 1 I know, based on what I have so far, angle 1 and angle 6. So I'm going to say vertical angle to angle 6. Angles, and that was 142. All right, so I'll put 142 in there. Okay, angle 2. Well, right now I can do, based on the information that I have written so far, I can say linear pair to angle 1 or linear pair to angle 6. Either one. Either one of those must be right. So this is going to be 38, and this is going to be a linear pair. And again, you can pay linear pair to angle 1 or linear pair to angle 6. All right, 3. Well, I've got 6 is 142. I've got 3, so I can say 142. All right, if I put 142 here and I want to base it on 6, this would be alternate interior. So I would say alternate interior angles with or to 6. Okay. If I did 1 and 3, then I would say corresponding to angle 1. So you got different answers. There's no one right answer to this. There could be several different ways to do this. All right, 4. Let's see. 4, based on the information I have, I'm going to do this guy again. So I'm going to say 4 is 38 because of a linear pair with to angle 3. Okay, that's all I've written down here. This is now 38. Okay, angle 5. Now 5's up here, so I can say, let's see, based on the information I have written here, I might say linear pair. Again, this is 38. Linear pair, and again, you have two different answers. Linear pairs with either 1 or 6. Okay, either one. Okay, number 7. 7. Let's do something other than linear pairs. Let's do something even better. Okay, so if I have 6, 6 and 7 would be considered, because we haven't used it before, consecutive interiors. Consecutive interior 2, 6. 6. And that, again, is going to be 38. Okay, last one, number 8. So 8, other than linear pair, I could go vertical angles, linear pair, or I'm going to do something different. I'm going to do alternate exteriors. Exterior angles to angle 1. Okay, and again, that's 142. So over here is going to be tough for me to grade because you could pick alternatives to some of these. Some of these you can have alternate answers. Like number 8, since it was the last number, I could get it several different ways. I could do linear pair, I could do vertical angles, I could do linear pair, I could do alternate exteriors, I could do corresponding with 6. So there's 8. I mean, this thing here has multiple answers, so I would have to literally go and look at your picture when I go to grade this. All right, so on the next page, I'm not going to go crazy with this. All you need to really understand, I'm not going to have you do these kind of really super complicated ones, but I wanted to talk about this one really quickly. This is just, again, 3 lines, 3 parallel lines cut by a transversal. So this is the transversal, and these are the 3 parallel lines. So if you want to, like when I'm doing some of these, sometimes I have to orient myself. I like the vertical lines to go left to right, and then I like to put my transversal here because I kind of read this as, oh, here's my group of 4, here's my group of 4, here's my group of 4. Now the idea here is if these 3 lines are traveling the same way, and this line is coming through it, like this, bam, it's shooting through it, that it's hitting each one of these lines in the exact same angle. So the idea here is angle 4 is the same as angle 5, which is the same as angle 6. 1 is the same angle as 2, is the same angle as 3. 12 is the same angle as 11, which is the same angle as 10. So it's, again, it's just 3 of them versus 2 of them. So even if one were missing, let's say the guy in the middle was missing, you still could do this problem. Again, that problem would be like the one we just did. So they can kind of, so this is fairly easy. This problem has 2 parallel lines, and then they've got a couple of transversals. But again, what I would do is use that post-it note trick we were using last time and just cover up what you're not using. So you could cover up, so let's say I had this guy and I wanted to pay attention to that one, then I'll like kind of figure out how I can ignore maybe a little bit this line here and only focus on that line. It all depends. But again, I'm going to stick to the fairly easier ones. These get a little complicated. Lot complicated actually. So not that it's super duper hard, you just have to keep track. And again, I would do the cover up thing. So like for instance, if I were doing something with angles 10 with any of these 8 angles, I would cover this one up so I'm not looking at it. And if I were working with these 8 angles, I would cover this up so I wasn't looking at it. And that kind of thing, if I were doing something like that. So example 5 actually looks a lot less complicated than example 4. Of course, seems to be a little bit difficult. All right, so the last thing we're going to talk about in this lesson is how to do the algebra. So the algebra is playing along the same lines as what you've been doing, except instead of just getting numbers, you've got expressions to go in their places. So you just kind of have to think about, well, if these are parallel lines, and this is my transversal, these guys are traveling together. Actually, they should, if it's saying if we make them parallel, then what can you tell me about angle 58 and this angle here? And again, think about what these are. These 2 angles were considered corresponding. Remember the group of 4 and the group of 4. That 58 and that 5x minus 2 are in the same place in those groups of 4. So therefore, your equation is going to be 5x minus 2 equals 58. Remember, when we do these problems, either it's equal to 58 or it's equal to 180 minus 58, which is 122. So it's either going to be equal to 58 or 122. Now, so any of these problems that we work on, it's either equal to it, congruent, or it's what's called its supplement, or what adds up to be 180 degrees. And you just really kind of have to look at it and say, are these the special angle pairs? And if they are they equal or are they supplementary? That's the question you ask yourself. So for instance, this one. All right, if you notice also, see how this angle is big, which is called obtuse, and this is acute, the tiny little one. Every single one of these angles that are formed here is either acute or obtuse, and it's always the same. In these problems, it's either the angle or its supplement, which means it adds up to 180. So in this case, are these two, these are considered alternate exterior. Remember, we mark our pictures. Here's interior, here's exterior, here's exterior. They're both on the outside and they're on both on either side of the transversal. So that makes them alternate. So that means that they are, they are equal to each other. Plus, like I just said, it's either obtuse or acute, and this is obtuse. See how big it is? And this one's obtuse, so it's bigger than 90. This one's bigger than 90, so that means they're equal to each other. And then you would just solve this. All right. I'm keeping the video short, so I'm not doing the solving part of it, but because I know you guys know how to solve equations. All right. So number 3, again, we got this angle here, and we got this angle here. And we've got our transversal. Let me just highlight the transversal here. All right, so if you notice, they're on either side of the transversal. Again, sometimes I have to turn them so that the parallel lines are going left and right and the transversal is going up and down. This is on alternate sides of the interior, so that means these are equal to. And then I would solve it. All right, this one. Okay, here's my transversal. Okay, here's the interior, here's the exterior. All right, these guys, this 9x plus 2 angle and this 133 are on the same side of the transversal, same side of this red line, yellow line, and they're on the interior. So these are considered consecutive interiors, which means they are supplementary. And again, if you need to go back to that first page and kind of refer to it, you've got all the different ones, but again, the question that I give to you is this angle right here and this big angle here the same size? And the answer is no. This one's acute. It's big, less than 90. It makes less than an L, and this one's bigger than the L shaped, the right angle. So this is obtuse. So when one's acute and one's obtuse, that means you have to add them up to be 180. So that your equation would be this. This angle plus the 133 is equal to 180. So every single one of these equations is going to be equal, like they were in the first 3, or set equal to 180, either or. That's why it's important for you to be able to get the equations first, and then I know you understand the geometry, and then solve it later. Again, if you mess up on the algebra, you'll get pinged a little bit, but not massively if I see your equations. All right. Okay, so we got this angle. Again, this one is bigger than a 90-degree angle, and so is this one. And again, remember, a 90-degree angle is one that makes like an L. So if you have to spread your fingers wider than an L, that means it's obtuse. If you can pinch it together, then it's acute. And these are considered alternate exteriors, because remember, this is my transversal. Okay, so these are alternate exteriors, which are always equal. So this time we're going to do and set them equal to each other and solve. All right, so either the same size or they're not. If they're not, you set them equal to 180. If they are, set them equal to each other. Okay, all right, so this one, again, acute angle, also known as correspondings, because in this group of 4, this is in the upper or lower left, and in this group of 4, this is in the lower left as well. So they're equal to each other, so that's what you're going to do with the equation. Okay. All right. Okay, let's jump down to one where they've mixed x's and y's together. Don't let that freak you out. You just have to keep in mind, don't mix the variables. So you want to write an equation with the variables, and then when you get an answer to one of these angles, then you can work with that last piece. All right, since these two both have x's in them, I'm going to solve for x. This angle and this angle, again, are the same size. Okay, so that means they're equal to each other. So I'm going to do this, and I'm going to solve this one just to show you what I'm going to do with it. All right, so I'm going to solve this. Okay, now that I know what x is 17, I'm going to put it in either one of these. Remember, they're equal, so it doesn't matter. So I'm going to put it in to 6x plus 3. Okay. All right, so that's going to give me, what, 100 and, let's see, 42, 102? 102, I think. Let's see, 17 times 6. 2, 4, 102, yeah. So 102 plus 3 is 105. All right, so this is 105. So if this is 105, this can't be 105 because these are consecutive interiors. This has to be equal to the rest of the 180, which is 75. So now I'll solve that. Okay, and then I'll solve that one. So it's a little trickier. This is actually, if you're taking the SATs, this is a great one for the SATs because that makes you find the answer to two different letters. Okay, so that's how you do that. So in this one, okay, here are I got one thing with y's and two things of x's, so I'm going to do these two things of x's. Now I'm going to do this. I know this is what's called a linear pair, so I know I'm going to add all these up and set it equal to 180, get my answer, plug it into, it doesn't matter. I would say this one, because then this one and this one are equal to each other. And so this would be 13y minus 17 equals whatever the number is I get. So that's how that works. So good luck with it.